All right, let's dive right in. We're talking about prompt engineering today. And look, this is a skill that has quietly gone from this kind of niche art form to the absolute bedrock of modern AI. It's the craft of translating what we want into precise machine action. And believe me, this isn't just about asking better questions anymore. It's about building a whole new kind of code.
You really have to let this quote from Andrej Karpathy sink in, because it completely reframes how we should be thinking about AI. It forces you to see your words not just as a conversation, but as commands. You're not just chatting with a bot, you are literally programming a brand new kind of operating system, and your prompts? That's the source code. But all this power brings a really fundamental challenge, what we can call the scribe's dilemma. The incredible capability of these models is matched only by their, well, extreme sensitivity to how we phrase things. The line between a brilliant, insightful output and a completely useless one can be razor thin, and it's all drawn by the specific words we choose. And here it is in action. It's so clear. On one side, you've got a vague prompt that gets you a generic, almost useless response. On the other, a properly engineered prompt acts like a focused beam of light, unlocking incredible, high-value performance. And I'm not exaggerating. Studies have shown that just reordering a few words can cause these massive swings in accuracy. It often feels less like science and more like, alchemy.
So, how do we get away from that unpredictable alchemy and move toward a real architecture? Well, we need to understand the underlying grammar of instruction. It is time to move past just trial and error and into a structured, repeatable methodology for building prompts that actually work every single time. The best way to think about a high-performance prompt is like you're briefing an expert. First, you give it a persona. Are you a senior coder today, or maybe a creative copywriter? Then you lay down the system instructions. Those are the ground rules that are not going to change. You ground it with contextual data, all the specific facts it needs for this one task. Then you show, you don't just tell, with a few key examples. And finally, you define the exact deliverable with output constraints. See? Each component just layers on top of the other to shape that final result. Structure is every bit as critical as the content. AI models have this weird quirk, a lost in the middle problem, where they can literally forget instructions if they're buried in a super long prompt. The solution is something called the sandwich method. You state your main instruction at the very beginning. Then you provide all your context and details in the middle, and then, this is the crucial part, you restate that core instruction at the very end. This just keeps the model laser focused on the main goal. Okay, this is where it starts to get really, really interesting. Because even the best structured prompt is going to fail if the task requires actual reasoning. So now we're moving beyond just telling an AI what to do, and into the world of guiding how it thinks. This is the absolute key to unlocking complex problem solving. Take a multi-step reasoning problem, like this one here. If you ask an AI to just spit out the answer, it's actually surprisingly likely to get it wrong. And why is that? Well, because it can't just leap to the conclusion. Just like us, it needs the time and the space to actually work through the logic step by step. And here's the proof. Look at these numbers. When Google's Palm model was given math problems with just a standard prompt, its accuracy was frankly a dismal 17.9%. But just by asking it to reason step by step using a technique called chain of thought, its accuracy just skyrocketed to over 58%. That is not an incremental improvement. That's a total paradigm shift. So the technique behind that huge leap is called chain of thoughts, and it's almost ridiculously simple. Just by adding a phrase like, let's think step by step, you force the model to slow down and show its work. It externalizes its whole reasoning process, which not only gets you a more accurate answer, but it also gives you a transparent thought process that you can actually look at, audit, and even debug. Now, if chain of thought is like following a single path through the woods, tree of thought is a full-on expedition. Instead of just one line of reasoning, it explores multiple branches at the same time. It's kind of like a chess grandmaster evaluating different moves, pruning the bad ones, and only pursuing the most promising lines of attack. This is absolutely essential for complex planning or creative strategy, where your first idea is almost never the best one. The React framework takes this even further, turning the model from just a reasoner into an actual agent. It creates this powerful loop. The model reasons about what it needs, it acts by calling a tool like a search engine, and then it observes the result to plan its next move. This is how an AI breaks out of its static data bubble and starts to actively engage with the live external world.
Okay, so all of this points to a really fundamental shift in how we need to think. To truly master AI, we have to stop focusing only on the prompt itself and start designing the entire information environment it operates in. This is the new discipline of context architecture.
Modern models can now process just immense amounts of information. I mean, some have a context window of 2 million tokens, and a token is basically a word or part of a word. That is the equivalent of feeding it several novels all at once. So the challenge is no longer just about fitting information in, it's about managing that information so the AI can find the critical signal in all of that noise.
This analogy from Lance Martin is just perfect. Think of the LLM as the processor, the CPU. But its context window is the RAM. It's the active short-term memory. And just like an operating system has to manage what's in RAM, context engineering is the practice of carefully curating what goes into the model's working memory at any given moment.
So on the one hand, you have what's called context poisoning. That's just dumping everything into the model's memory, creating a ton of noise and confusion. The elegant solution to this is retrieval augmented generation, or RAG. This is an intelligent system that first surgically retrieves only the most relevant information from a knowledge base before it ever sends it to the model. It's the difference between brute force and surgical precision.
This brings us to the final stage of our journey, the moment where the artisanal, handcrafted prompt gives way to something far more powerful: programmatic, automated systems. You can think of it as a modern scriptorium, but it's run by machines.
Let's just be really clear about this. This isn't a metaphor anymore. Prompt engineering is the new coding. And just like any other programming language, this means we now need compilers, optimizers, and frameworks to manage all that complexity at scale.
Frameworks like DSPy are really leading this charge. With DSPy, you stop trying to write the perfect magic sentence. Instead, you declare the high-level steps you want the AI to take, the logic of your workflow. The DSPy compiler then does all the heavy lifting, automatically testing and optimizing the underlying prompts to find the most efficient instructions for that model. You just focus on the what, and it figures out the how.
And this is where we get to a fascinating kind of meta level of engineering. With automatic prompt engineering, or AP, we're literally using one powerful AI to train another. It programmatically generates and tests thousands of prompts. It scores their performance, and it iterates to find optimal instructions that a human would probably never even think of. The engineer's job isn't to write the prompt anymore, but to design the system that finds the prompt.
So let's just recap this whole journey. We've really moved from art to architecture. It all starts with a foundation of absolute clarity in your instructions. Then you induce reasoning with techniques like chain of thought. Next, you architect the context with powerful systems like RAG. And finally, you automate the instructions with programmatic frameworks. And this architectural approach, it's not just theoretical. The impact is real, and it is measurable. When these techniques are applied, they allow developers to code over 55% faster, and they help professionals finish writing tasks 40% more quickly. This isn't just some small optimization. It is a massive, tangible leap in productivity, all of it driven by better instruction. Which leaves us with one final, and I think crucial question. As we become the architects of these new systems, using prompts as our literal building blocks, we have to ask ourselves, are we constructing enduring cathedrals of intelligence? Or are we just building elaborate, fragile houses of cards? The answer, I think, is going to depend on the rigor, the responsibility, and the foresight we all bring to this new kind of code.